Hello friends, welcome back to the channel. It's been a minute. I have been on vacation and I had a good time with the family, but I'm also glad to be back working on Natalie and some other programming projects. Lately, I've been playing with LLVM and made this little tiny Hello World compiler. It just compiles a call to printf and libc and passes hello world, and it does it in LLVM and then it executes it. So that was a lot of fun, kind of learning how to do this, and I thought it might be fun to make a little compiler that could compile a subset of Ruby syntax and it be statically typed. I've never done that, and I've never done LLVM, so here we are. We're on the edge, the very edge of my knowledge, and kind of out on a limb. So if you've been watching this channel for any length of time, you know that's how I operate. I'm a lifelong learner, and I'm always going to be making videos about stuff I don't fully understand. So if you want to learn with me, then hang out and we'll see what we can do. But this is definitely not a how-to. This is Tim struggling through and trying to make something work. All that out of the way, let's jump in and where to start. So I think what I want to do is just start in with the Natalie repo, not make a new repo yet. I can extract it later because I want to use our parser. So let's just do, I'm just going to call it LLVM for now, and go look at our parser header here and kind of remind myself how it works. So you instantiate a new parser, you pass in the code string and the file name, and then you call tree, and you get back the AST. And this is the parser we rewrote for Natalie. So it's a Ruby parser that's it's getting better, but it's not quite done. It's probably good enough for today. And then I want to bolt that in with the LLVM code that I had been playing with. So let's just copy this into a new file, and we'll put it source. Man, I need a better name. I am just going to call it LLVM for now. LLVM CPP, and let's paste that in. And I guess I need Natalie parser. I'm not sure what else I'm going to need, but I need to create a parser here. So I guess this is just parser. I'm not sure which syntax I like. I keep going back and forth, but let's do it this way. Parser, new string. I guess I need Natalie string. We'll just say 1. And new string. I just need to pass something here. It doesn't even have to make sense, really. Parser, use of undeclared identifier parser. I guess I should do use namespace Natalie. Does that fix that? And then we also need our rake file to have a job for this. And I'll just put it here, I think. Would it be I guess it'd be a file, wouldn't it? Yeah, let's actually go down here to files. It's kind of going to be like this one. Let's go put it right here. So I'm going to say file, bin LLVM. Let's put it in bin, and then let's say it depends on source LLVM CPP plus all the headers, and we're gonna need this. Did I not reload this? I thought I changed this. I thought I had, okay, well, I must have messed this up. I messed it up. I deleted this. Oh, I'm putting this back. Yeah, there we go. Okay, that helps. So I need all of these flags in here, I guess. Let's just paste this in and see what it looks like. So we got clang++. This definitely has to be clang, I believe. I think you can do with GCC somehow, but I'm not gonna go there. LLVM flags is, we're just going to shell out to get that. LLVM flags, CXX, LD, system, yep, okay, so we'll do that. And then that stuff is all normal, and that can go away. And then I guess we'll just put the LLVM flags right here. Standard, I don't want it to be, yeah, I think that's what I want, maybe. T.source. I hope T.source is the first item in this array. I think so. Yeah. So let's just see if we can get. Let's just see if we can get this to build at all. So I should print hello world if it builds. So bin LLVM. No input files. No input files. This has a bunch of new lines in it. That's cool. So I guess I have to gsub new lines for just a space. Let's try that. That looks better. Can I use throw with exceptions disabled? Well, no exceptions. I guess that's the default flags. Fun. Well, I'm turning that back on. Probably breaks LLVM somehow. I don't know. We'll see. We'll see what happens. Could not find variable specification and offset. Blech, what is that? Oh, I'm not linking with lib Natalie. So I guess I have to do L Natalie. I have to do capital L build. Yeah. Let's try that. Okay, cannot find same thing. Build Natalie ls build. We have build in here. We have libnatalie.a here. I never know if I should have to do it after the. Maybe I should do it at the end. Oh, build Natalie. How do we do it in compiler RB? Libraries, link flags. We do it after the code. Yeah, so maybe that matters. Sometimes I think it matters. Let's try that. Okay, that's good. Bin LLVM. Does that print hello world? It does. Oh, that's so cool. There's this other cool thing here. If you want to see the IR code for that, let's do make bin LLVM and run it. Oh, not make, rake. So we'll actually print out the IR for like the human readable IR for what the LLVM, which I think is pretty cool. So I really like how readable it is. I mean, it's not C readable or C++ readable, but it's not bad. You can almost kind of figure out what's going on here. We have a string that's null terminated that is set to @0, and then we're calling the printf function, which we've declared with its type here, and it takes a variable number of arguments, and then we're assigning the result of that to %0 and returning 0 from the main function. So that's pretty cool. I don't know. I had a lot of fun playing around with that. So now let's get back to our parser. What can we do with this parser? We can say all I want for today's video is I just want to print out the number 1. Okay. There's not a lot here. I just want to print out the number 1. So what, I guess I want to emit some LLVM instructions for each node in the tree. So let's do tree is parser.tree, and we'll leave the printf. And instead of calling it with our string, I'll just comment this out. I think I want to walk the tree. Let's say walk tree. We'll make a function walk tree, and we'll pass in the builder, and we'll make it do something. I'm not sure. Node star node. I believe that's what that is. And this is I don't know. What type is that? What type is that? Rake. I put a char there just so it can tell me what, there it is, IR builder. That's what I want. That's how you cheat, IR builder. And does this compile now? Marked deleted here. I guess this, oh right, let's make that a reference. Okay. Is a little confusing. Oh, right, because I'm not printing hello world anymore. So good. That's why I didn't print anything down here. And so let's walk the tree, and we'll say switch node type. If it's a node type integer, then do something. Break default printf. I don't know how to handle node type. We'll make this an int, and then we'll abort. So we want to do something here. Indent that. There we go. What do we want to do for integers? Well, we know how to do an integer here, so let's just copy that. So constant int get, I guess make this a 64, which I don't have. I32, I guess I need this. Some little curlies around that, and make this a 64, see, and then instead of 0 here, we want it to be node. I think I have to static cast that. Static cast integer node number. So call this num. Then let's call printf. We do need a format string, I guess. So let's copy this up here as well. So %i you know, I guess it's going to be a long by the time I convert it. I don't know how to convert it yet. Whew, that could be interesting. We'll see what we got to do. So printf function. I'm going to have to pass that in. Ugh, I don't like that. I don't know what kind of, I don't know what type that is either. This is gross, and that's okay. That's totally okay. We're experimenting. So format string. For now, let's just say what up, and create call print. Right. So give me an error so I know what type that is. The type is function type pointer. I don't think I need this LLVM thing here. So does that make it happier? What is this complaining about? Braces around scalar initializer, fix available. No matching function. Why not? Why not? What do you mean? This one's confusing. No version from function star to function type. Oh, function type star. Passed the wrong thing. Function. Oh, it's not function type. It's just function, right? Function. I don't know where I got function type. Okay. Function pointer. Function pointer. I don't know how to handle node type 7. Okay, what is node type 7? Node HPP type 7. 7. Oops. Whoa. Okay. 7 down is a block. All right. Block has what? Come on, block node, where you be? There you are. Block node has many nodes. That's right. Okay, so for a block, I guess we want to say for auto in static cast block nodes star node nodes in the block. We want to do something. I guess we want to walk the tree with that node and the builder and the printf function. Don't really need the curlies. Don't need these curlies either. But what are you complaining about? Indirection requires pointer operand. Vector invalid. Is it the parens? What am I doing wrong? What are you complaining about? Where's pointer operand? Does that return? Oh, it returns a reference. Okay, so I don't need these. Cool. Walk tree, and then we're gonna do. Yeah, I know you're not using that. That's okay. Let's see if this compiles. What up? What up? It is curious that we printed what up twice. Because all I parsed was a single one. Why did we print what up twice? Interesting. Create call, builder, create call, print F. Okay. I don't know. We'll figure it out in a second, I guess. So here I want I actually want the number to be printed. So I think what I need is to pass in the num here, but I don't think that's the right type. If it is, then yeah, it can't be. I have to turn this into a long. Let's just see what happens. Maybe the error will help me, but I think it's going to be a seg fault. Actually worked. That actually worked. Does LLVM convert that for me automatically? Or does i64, is that just, like, what type is this? What type is this? Constant int pointer. It has to do it for me automatically. I mean, it did the same thing for string, so I guess I shouldn't be surprised. Like, this is obviously not a char pointer, but it converted for me. Cool. So it also converted that one for me, I guess. Let me know in the comments if you think I'm making a big blunder here, but the fact that that worked is pretty cool. Now, second thing, why is it printing this twice? Why? So if I give it a 3, is it going to print 3 twice? No, it is printing 3 and then a 1. So where did the 1 come from? Where did the 1 come from? Are we here twice? Hello? I mean, I think we are. Our AST that gets returned is returning a 3 and a 1. So there are 2 nodes in the block. No. Oh, break. Boom. Helps if you put a break in your switch statement. The fact that I guess it static cast that block node into an integer node, and then, whatever data was in that slot, it looked like a 1. So that's what happened. Well, look at that. Bin LLVM. We're printing a 3. Oh, that's so cool. So what if we did int arg count char arg v, and we did assert arg count is greater than 1, I believe. It's been a while since I've done this. We'll say arg v1. We'll turn that into a string. That way I can just pass in whatever I want. And we'll say 4. Yes, and do a big number. It works. So I know that's not very spectacular, is it? But let's actually emit the LLVM IR so we can see kind of what that looks like. Oh, that's so cool. So here's my format string. Here is me calling printf with the format string, which this is very confusing. This get element pointer, I've read a few docs about it and I still don't understand it, but so far I don't really have to, because the API of making this call that we did up here took care of all that for me. So that's pretty cool. I64 and then my big number. And then we're returning 0 from main, and that's so cool. Well, since that didn't take too long, what do you think about doing strings? What do you think about doing strings? First thing though, what does this work with 2 numbers? It does. It does for 3. And I can pass in as many numbers as I want, and it's going to just print them out. So what if we did strings? So if I pass a string in here, it's going to say, I don't know how to handle node type 55, but I could add a section here for string, and then what? I guess I'm going to copy this. And so instead of an I64, well, let's just delete all that. Let's say we want to static cast this to a string node, and I forget what just string, I think. Auto string is that. And my format string will be %s, and we'll just do builder.create global string pointer, and we'll pass this in. And I think I have to do C stir here, and we'll say that, and we'll print this. That didn't work. %s. Huh? What did that do? Maybe I should put printf. So what exactly happened here? Just printed %s. Why did I do that? Format string printf %s. Well, it worked up here, right? So if I give it a 4. No, I broke something. What did I break? Wild. 4-3 foo. Weird. It is dumb that I'm duplicating these. Foo %s. So why did these two print null? And why is that printing %s? What have I done?
A few moments later.
Okay, check it out. I figured it out. I don't know exactly why, but with this set to interpreter, it doesn't work. But if I set it to JIT, and I had to add these LLVM initialize native target, native ASM parser, and native ASM printer. Without these, I get, I think, an error of some sort. Yeah, target does not support MC emission, but if I re-enable these and I set this to JIT, everything starts working. And so now it says foo bar. So we can give it that longer one now. And it says 4-3 foo bar 1. So we have strings and numbers, and this is so cool. I would probably do some work to split these out so they're not being repeated. Just set them once and reuse them. But I think this is a really cool start. Super excited about that. I wish I knew why the interpreter doesn't work here. But maybe I'm okay with it using the JIT for now. Maybe I will learn more as I go, but this was pretty cool. This is pretty cool. Yeah, so I don't know. Maybe in the next video, I'll try to either do variables or some sort of function. What should I do first? Probably variables. Being able to set a variable and then being able to set it to the right type. So that would require a little bit of, kind of rudimentary type inference, I guess. I mean, we know what type the value is. So if you have x equals 1, then I know this is an integer, so it should set the variable x to an integer. So yeah, that'll be fun. I can't wait to do that. But I think that's it for this video. I feel really good about what we got done here. We hooked up the parser to LLVM. We are walking the tree, and we're able to convert 2 different node types, integers and strings, into LLVM code. And granted, we're just doing a printf right now, but at some point we'll be able to admit some instructions that actually make sense. And when we get variables, we'll probably will we be able to remove the printf? I mean, we'll still need to be able to see it, right? Yeah, I don't know. We'll get there when we get there. I'm getting ahead of myself, but thanks for hanging out in this video. I hope that you found that interesting. I hope you learned something. I definitely did, and still don't know why the interpreter didn't work, but that's okay. That's okay. Maybe this is better anyway. Thanks for hanging out. I hope to see you next time. Bye.